And we're continuing on in chapter 1. Move this out of the way. And next topic is distinguishing object references and primitives. Java application contain two types of data, primitive types and reference types. Now, primitive types, Java has 8 built-in data types referred to as our Java primitive types. These are basic building blocks. Most of these you've used in some form. Well, maybe some of them you've used. Double, maybe float. I don't remember if we used that at all in this class. Integer we used. Maybe 2 or 3 of them were used. But these are your building blocks, everything else. Boolean, true or false, 1 or 0, so forth. Byte, 8-bit integral value. Short, 16-bit integral value. They give you examples. Integer, 32-bit. Long is 64-bit. Then you get down to float, which is 32-bit, double 64-bit, and characters are 16-bit Unicode value. Now, you might be looking at the example and say, well, they're all the same. Yeah, in this case, they are. The idea is that they all represent integers, these 4 right here. But there's certain limitations on what sizes you can put in there. How big can the number go? Why wouldn't you make everything long? Then you're covered. Well, the idea is to use as little resources as necessary when you're writing a program. Same thing with float and double. Why use a double if you can use a float and use less memory? Now you see the F on the end of this here. It's common in many programming languages to, if you got a number to specify it as float, you put an F on there. Let's see. You won't be asked about the exact sizes of most of these types. You should know that byte can hold from negative 128 to 127. It says here, let's look at how Java gets us. A byte is 8 bits. A bit has 2 possible values. Their basic computer science definition you should memorize. 2 to the 8th is 2 times itself 8 times, which gives us 256. It says 0 needs to be included, so Java takes it from the positive side. So it goes from negative 128 to 127. Excluding 0, that's 256 values. If you've seen this in Introduction to Computer Science or Introduction to Digital Design, you know that 8 bits. You have 8 blanks here. One, two, three, 4, 5, 6, 7, 8. I could have 1 there, 1 there. And then 1 there. This is over here 2 to the 0. This next one is 2 to the 1st, and so on. So it'll be 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th. 2 to the 0 is 1. 2, 4, 8, 16, 32, 64, and 128. So if we, the largest number, if we have this many bits, if we add all these together, that gives us our largest number. There's more to it than that, but when they're talking about bits and limitations, that's what they're referring to. Each bit can either be 0 or 1. I never sit there and do the calculation. I always just Google it. I'm trying to see how big of a number it can hold. So it looks like Java has a way to do that. Integer dot max value. System dot out dot print line integer dot maximum value. Save that. Let's see. 2 billion, 147,483,647. So if you were working with something greater than 2 billion, that obviously would not be enough. And I don't know how many, well, that is. Let me see. This is million, billion, trillion, bazillion, gazillion. I don't know what it is beyond that, but that's a pretty big number. But there's still limitations on it. So I'm in Excel. And we'll take this number, put it in here, and put that number in here, multiply two together. I don't know if I can get that any way to actually show those. Doesn't look like it. Because we're way into the zeros. And I don't know how many showing there. Okay, so let me Choose general numbers. Still waiting to 0, still not doing it. So switch to scientific. Number. There we go. I thought I copied this. 807. Try it again. Maybe I didn't get to sleep last night. 807. Okay, now I definitely got 807 there. Ninety-two, 3702, 036, 854, 77, and then it's putting zeros for the last four. So is Excel going to have issues, do you think, if I'm working with numbers that huge? Obviously, some. It takes my last four digits and puts them all as zeros. So that's weird. Um, when we multiply these two together, um, all these zeros here at the end. Um, if I take 100 times 100, equals this times this. Two zeros here, two zeros here. We have four zeros here. Four zeros here, four zeros here. Looks like we have a lot more than 8 zeros. So it's not doing the calculation at all correctly. It's changing some digits after a certain point, just all zeros. It's maybe close, but it's not going to be exact. There's Wichita State used to have a class where if you went onto there, and a lot of four-year colleges probably have the same programming project, but they have you deal with situations like this. Because if you're going into programming some kind of scientific area where you needed to have precision, these standard primitive types in a lot of programming languages do not handle it. And what they have you do, I've had students from Wichita State come back and tell me this, is you put these into an array. So 9 goes into its own spot in an array, 2 does, 3 does. So it's an array of single digit numbers. This one would be an array of single digit numbers. And then you, through for loops and really thinking through the process, you multiply those together by multiplying array entries together and carrying and so forth. I always thought someday I'd sit down and do that because it just sounded like a real challenge. Students said that it was a very hard program to write, but I don't even know how you can check it. If you don't have like Excel or something to fall back on. But that shows you some of the issues with working with huge numbers. Now, I never had to work with huge numbers, so never really impacted me. Everything I worked with was fairly small, and I never exceeded limits of the primitive data types. Okay. Here they talk about some of the issues about that, and you can read that. Here's another way to specify numbers: change the base. When you learn how to count, you study digits 0 through 9, but there's other ones like octal, which is 0 through 7, hex, which is 0 through 9, and then A through F. The A represents 10, B represents 11, C represents 12, and so forth. So it goes from 0, and F is equal to 15. You got binary, which is 0 and 1. And it says you won't need to convert between number of systems on the exam. But this is good to know because in various parts of information technology, you'll run across these. And some of you have seen this if you're working with networking. And I didn't do a pause or more or whatever DOS is. See a physical address down here. This is in hex. So this is not in decimal. I'm guessing this is in hex, what it looks like. Well, what does that matter? Do you have to actually convert these? Well, they got nice converters to convert back and forth between them. I found one web page fantastic in that regard because it allowed you to easily switch from one base to another base. It had a whole bunch of bases. It must have had 30 bases on the page. You put the number in one of the bases, and it shows you all the rest. Because you're not limited base 16. You got a base 23. I don't know what you do if you ran out of letters, because 0 through 9 is 10 digits, and then you only have so many alphabetical letters. But I suppose you go to Greek or whatever other letters needed or symbols. But anyway, at some point in time, you'll run across hex and so forth. Don't necessarily have to be an expert at it, but you should have a basic understanding of what you're looking at. Here's how you represent different bases. You see here we got the number 1 1, and the number 1 1. I forgot Notepad's still going. If these were gone, stop. Then this is 2 to the first or 2. This is 2 to the 0. 2 plus 1 is 3. And that's what you're telling you. That 1 1 in binary is equal to 3 decimal. That B represents binary. A lot of these are pretty obvious. Seems like something's missing there. Like you had to have an O. 017. Let's go ahead and try that. Sure enough, prints 15. How in the world does it know 15? Prints 23. But if I put a 0 in front of it, it assumes octal? It's 2319 in octal. Or I mean, it's 23 in octal 19. 8 to the 0, that's 3. 8 to the first is 8 times 2. 16, 19. Yeah, sure enough. That's a puzzler. I would have expected you to have to put O there. Okay, it's 56. Binary is B, that's standard. X is standard for hex. And then automatically converts it. Octal. Then comes octal or base 8. The rightmost digit is 7, is worth 7. The second doesn't specify why I put in a 0, and no specifier is octal. They don't consider worthy enough to even say why. But anyway, that's how you can work with different bases by putting 0B, and I guess if you just put a 0 in front of your number, it assumes octal. Underscores numbers make them easier to read. That's an interesting one. I don't think I'd ever do it, but looks like you can do that. You can add underscores anywhere except the beginning of a literal, the end of a literal, right before a decimal point, or right after a decimal point. So can't have the underscore at the beginning, at the end, before the decimal, and that one's okay. This one compiles. Yeah, that one's okay. Annoying but legal. Okay, reference type. That was our primitive types. Reference type refers to an object, an instance of a class. Unlike primitive types that hold their values in memory where variables located, references do not hold the value of the object they refer to. Instead, a reference points to an object by storing a memory address where the object is located. A concept referred to as a pointer. Unlike other languages, Java does not allow you to learn what the physical memory address is. You can only use reference type to refer to the object. Let's take a look at. I don't know. Let's take a look at some examples that declare and initialize reference types. Suppose we declare a reference of type java.util.date and a reference of type string. The today variable is a reference of type date. It can only point to a date object. The greeting variable is a reference that can point to a string object. And then a value is assigned to reference in one of two ways. A reference can be assigned to another object of the same type, or a reference can be assigned to a new object using the new keyword. So like these assign these references to new objects. Not too exciting from a programming standpoint. What they're talking about is the storage of those in memory. There's some programming languages, not all of them do the same type of concept, but there's some programming languages. Now I'll choose primitive types. We got this right here, and each time you change it in some form, it reallocates this in storage, and and from there it handles it appropriately. I don't remember what Excel VBA does. Let's take a look since I got Excel up and running. Assuming I can remember where Excel's at. There, the view. They have no place logical view macros. Test, great. And I don't know how to make that bigger. Tools, options. That didn't seem to do anything. I didn't say that. Oh well. Now if I run that, press 3. Let's see if this gives us an error or runs. 3 gives us type mismatch. So Excel VBA didn't do that. Some programming languages, what it'll do is it sees this and say, okay, that's the integer, and allocates memory for it. And then some, like right here, will since this is an integer and this is a string, it'll concatenate them together. VBA used to do this. This is really a headache, or not VBA, Visual Basic, and so it was a headache doing that. Now, I expect this would work with VBA. This is the programming languages that are weakly typed, allow you to just willy nilly go back and forth between the variables. You'll love it because it gives you total flexibility. You don't have to worry about converting things and so forth. Now here, A is pointing to a certain memory location. All of a sudden, I reassign A. It's still the same variable name, but I've changed the data type over here. So as a consequence, it points to a new location because a string refers to an array of characters. So it's referencing a place in memory. So it's no longer a primitive type. So you'll run across that where they'll talk about that in different books and so forth. Um, the allocation of memory, references, and so forth. And if you're writing a system utility, like you want to for the Linux operating system, you want to write a utility, then that's important. But for the average programmer, they don't usually write system utilities. Okay. Okay. Let's see. Key differences. A few important differences you should know. First, primitive reference types can be assigned null, which means they're not currently referred to an object. Primitive types will give you a compiler if you attempt to assign them null. So you can't assign an integer to a null, but you can assign a string to a null. And some programming languages make it a lot more clear. Strings in many, all programming languages, are an array of characters. In C, how you end it is with a slash. I don't remember if I remember which slash it is, but like David, and then you I think with that slash, but it might have been the other one. So in memory, you keep going with a string until you hit that /0. Now, a lot of programming languages hide that from you, but they do the same idea. Because if you got a string, how big can a string be? David was here today and will be gone tomorrow. Can I add more? I can add more. So if you really don't know how much space it's going to require, how do you know where to put it? And that's why it just references a place in memory. Say, okay, this string starts at 0A01B02 or something like that. And it keeps track of all that for you, so you don't have to worry about it. And but it just points to the start of the string. And then it uses some kind of indicator to indicate where does it end at. Okay. Let's see. Next reference types can be used to call methods when they do not point to null. Primitives do not have methods declared on them. In this example, we call a method on reference since it is a reference type. Integer, you can't call any method for it. But remember how some of these we've been referring to dot length. That's a method that's defined. This specifically is for a string, but remember a string is just an array of characters. But here, where we got len, which is our integer, you cannot have a method attached to it. The very worst programming languages I work with do not really go into, they focus strictly on the primitive data types and do not go into these reference types. Give me a good programming language that has a strong string capability. I love it. These ones where you have to assume it's an array of characters and work with it in that form. An array of characters means you got a reference to the start, and it's not the array that we're thinking of. Java's made that so much easier, as other languages have. Okay. Talks about variables, string, integer, declaring them, assigning them values. You can combine them together. I don't really like this format. This one's okay. I don't mind that. But for some reason, this bothers me. I don't know why. But you declare them and assign them equal to a value. You can put multiple ones in one line. I think it's because it's just so easy for me to overlook it when I'm looking at it. Let's see. This is where it gets tricky. Pay attention to tricky things. Exam will attempt to trick you again. Again, how many variables do you think are declared initialized in this code? I would expect, and I'll read the answer here in a minute. I would expect that 3 variables are declared and 1 initialized. Let's see if I'm wrong. 3 variables were declared and only 1 was initialized. Okay. Comma separates each one. But you can't do things like this, int num and string value. Boolean. So it's like it would declare two strings, S1 and S2, and initialize one of them. What it looks like. Let's see though. First statement is legal. It declares two variables without initializing them, which expects. Second is also legal. It declares two variables, also initializes them. Here, I don't think we can repeat double, but let's see. Third statement, not legal, does not allow you to declare two different types in the same statement. This one should be legal because they're separated with a semicolon. And this one should be illegal. Because you want to separate with a comma if you want to declare both of them as integers. Of course, I don't know, just if you can have a variable just sitting there by itself. If you want to declare multiple variables, okay. Fourth statement is legal. It does appear twice. Each one is a separate statement because there's a semicolon between them. Two completely different. Fifth statement is not legal. Again, we have two completely different statements on the same line. Fifth one. So I guess you can't just have a variable sitting there by itself. That'd be like in Java, where I just say, hey. I guess it doesn't allow that. Just not doing anything. Rules about identifiers. This goes over those rules. Name must begin with a letter or the symbol, $sign or underscore. Subsequent characters may also be numbers. Can I use a reserve word? That's curious. I don't see him saying anything about spaces. These are your, I believe, reserve word, or some of the reserve words. Reserve words in Java, constant and goto aren't actually used in Java. So you can't name your variables this. Seems like a short list. Okay, identifier, that should be fine. Starts with a $sign. I think that's fine. Underscore should be fine. Two underscores should be fine. All these examples are not legal. What's wrong here? Starts with a number. Has an @ symbol in it. Starts with an asterisk. Reserve word. Public is a reserve word. The good programming languages will tell you if you're trying to use a reserve word. It's Java. Comes up here, says doesn't tell us that, but it's giving us an error because that's a reserve word. I really don't do weird things with the variables. I make them kind of lengthy. I'll use underscores, but never at the front. I never use $signs. If it's even close to reserve word, I won't even use it. Every once in a while, I slip and use like some. But some languages, some is a reserve word. R, I think, is one of them. I got bit one time by using a reserve word, and it didn't tell me that that was an issue. And I started assigning it values and so forth, and it did not like it. It just did not work. It took me forever to figure it out. Um, Now you're going to find that there's certain reasons why you'd use some of these characters. I don't remember if it's in, I think it's in Linux, Unix, that if you start your file name with an underscore, that makes it invisible. I could be mistaking that with Windows or something. Um, in Linux, what does an underscore at the start mean? Yeah, it has meanings there. I forgot about that. But there's something with the file names that means something too. I don't remember now. Um, Used to be at IFR, I was trying to get front page to work. Front page is a nice GUI for building web pages, and I had set up an Apache server. It was on FreeBSD, which is a Linux variation, and could not get the front page extensions to work on Linux. And some of you have heard this story. I spent probably a week on it, couldn't figure it out. That's a long time. Be sitting there scratching your head and trying different things, not finding anything on the internet. Um, Finally went to my boss and I asked her, "Can I call Microsoft and figure out how to get this working?" And I figured since it's front page, which was a Microsoft product, it's no longer. I forget what they replaced it with. Um, that they would have the answer. So she finally relented. And it wasn't free. So it cost us like $120, $150, something like that, to call Microsoft. And they had me fixed in about 15 minutes. They were good. There was no, what version of Windows are you running? Uh, what's your virus check? I mean, they were right to the point. They knew what they're doing. That paid support is invaluable. And I could have spent another month on it and still not had the answer. Well, they got me fixed for that problem, how to set up front page extensions. And I asked them. I said, "Is the reason why I was having so much trouble is because I'm got a Linux server and I'm trying to set up Microsoft, which is a Windows product, on that interface together." And he said, "No, no." He said, that wasn't the issue." He said, "Front page really originally wasn't even a Microsoft product. They bought it. It was a Linux-based product." And he pointed out there's the underscores on there. And he says, "You see the underscores that are here? That's because it's a holdover from the Linux base." So again, that underscores mean something particular in files. I just don't remember what now. That was always my goal. Be smart enough to write a computer program that became popular enough that Microsoft would pay me a huge sum of money and I could retire and not work the rest of my life. Um, that's what they do a lot of. They're not geniuses at programming necessarily. They're just geniuses at running a software company. They'll look for products that are already written and they'll purchase those. And sometimes they purchase them just to take them off the market. And sometimes they purchase them to get that into that area. Um, they talk about what you should do. Says most Java developers follow these conventions for identifier names. These aren't set in stone, though. Method and variable names begin with lowercase letter followed by camel case, and that's how they change. They refer to that over here. Instead of having everything lowercase, you have it flip back and forth. This is my class becomes this is my class, where the T, I, M, and C are uppercase. So that's what they're referring to in terms of camel case. Up and down. Let's see. Class names begin with uppercase letter followed by a camel case. Don't start any identifiers with $sign. Compiler uses this symbol for some files. Anyway, you can read all that. You'll notice in my programming, I don't really follow any kind of conventions on that. Mainly because I don't work for a company anymore. If you work for a company, a lot of them have standards set up that they'll say they want you to name it following this pattern. Because it's best if it's standard across the board. So then you don't have to sit there and read somebody else's different code, and then somebody else's different code, and everybody has a different way of doing it. Coke, they were to the point where they told us what our start of our variables had to be called, and so you couldn't name a variable just sales. You had to have something on the front, and that symbol on the front would tell you something about it. Things might tell you if it's a local or global variable, so you don't sit there and go up and look for where it's defined at. Maybe it might tell you if it's like a working storage type variable, where you're going to temporarily use it, but it's not really important to keep the value. It's just used right there, but not used again. So there's a lot of different variations you can have on that. And if your company doesn't have that, then you should develop that yourself. So you should come up with your own standard to follow, because it really does make your code easier to read for yourself later on if you're looking at it and you're trying to figure out a program. Okay, let's talk about local variables. Here we got public int not valid, and we got y declared here, set equal to value. We got x declared, not initialized, and then int reply is equal to x plus y. The problem here is that x is not set to an initial value. And sometimes it even gets trickier. Some of these programming languages are smart enough to recognize maybe it'll never get initialized. Maybe. Like I got, let's see, A, B, and sum. And sum is equal to A plus B. System.out, print line, sum. You see where it's squiggles in here. Variable A might not have been initialized. And the flag is equal to 3. If flag is equal to 3, then A is equal to 5, B is equal to 2. I just initialized them, but there are little red squigglies under there. It says might not have been initialized. It's because this is smart enough to recognize that these are contained in an if statement, and it may not do what's inside that if statement. Now here, you see it got rid of our little red squigglies because it was smart enough to recognize no matter what code path is taking, A and B will have values assigned to them. Else if flag is not equal to 3, was it smart enough to recognize the all code paths are covered? Wasn't smart enough here, was it? So sometimes when I know that this covers all the cases, and I'll just come up here and I'll initialize these just to dummy values, just to shut up the compiler. I know that it's either going to be equal to 3 or it's not going to be equal to 3. Those are only possibilities, assuming flag is assigned anything. See if there says anything interesting here. Local variables is a variable defined within a method. It's only accessible within that method. Outside of this method, you cannot access X, Y, and reply. They do not have a default value and contain garbage data until initialized. Some programming languages will not give you that error compile time. They just won't work. Give you really weird results. This should be smart enough. Okay, yeah, it just says it's smart enough to see that. Find an answer. Here's what I was referring to. Only one branch is equal to 1 here, but in my else, it does not assign only one branch. Which means down here, this one works fine because answer is specified not only in my if, but in my else. But only one branch is only specified in my if. It's not specified in my else. So all code paths do not assign a value to that. Instance and class variables. Variables are not local variables known as instance variables or class variables. Instance variables are called fields. Class variables are shared across multiple objects. You can tell a variable is a class variable because it has a keyword static before it. So class variables are shared across multiple objects. Although we really haven't seen it in this class, Kyle, I think you've seen static before in game development, where we put static before it so we could access it in another class. So if we're in Unity doing the C# and you have two classes and you have one variable over here that you want to access from this other class, then you put static before it, and that allows you to update it directly. So it makes coding easy in that regard. Variable scope. Oh, they're different names. Yeah, this one's says pieces of cheese. This one says bytes of cheese. So they're saying there are two local variables here. This is a parameter, an argument you're passing in, and then this is a primitive type, a data type you're variable using within that method. Both of these only exist in the context of this method. After you're done running eat, you will not be able to access these two pieces of cheese or bytes of cheese anymore. Let's see, Boolean hungry, if hungry. See how int bytes of cheese is declared within the if statement. So it's not declared up above, it's actually declared in the if statement. Sometimes I'll do this when I'm doing something very quick, but then I'll correct myself and put the int at the top. And it says bytes of cheese go out of the scope here, which means you cannot access it outside of that. So very important to keep in mind, where does that variable exist? Sum is declared up at the top here, which means you can use it anywhere in this method. A and B, since I put the int inside this if part here, it only exists, this A and B only exists inside these curly braces. Once it gets out of there, it doesn't exist anymore. This is only declared inside the else. So after it gets out of the else, it's not used anymore. That's why it's giving me red squigglies down here. Like I say, sometimes I'll do this on the fly. I'll just put an int in front of there, being too lazy to go back up here. But you need to correct that. Otherwise, it might cause you issues. Usually it's a compile issue, not when you're running it. When hungry, if hungry. So this bites of cheese is declared right here inside of that. Bites of cheese, since this is in a block that's inside the block, means I can access it just fine here. But this one, teeny bit, where's teeny bit? Teeny bit is declared in the inside block, so I cannot access it outside block. Okay, so here I have this declared in the outer, and so all the inner ones can access A. I put A equals 3 here, it's just fine. Put A is equal to 5 here, it's just fine. Even down here, not an inside block, but just on the same level, I can access A. I cannot have another variable called A here. This is a little bit different than maybe what you've seen in some other areas. And then run test. I'm missing something. Okay, so now I'm calling test here. And I can call test here. When you have it declared in your own method, it's like it's taking this and it's placing it on a stack. So it's completely separate from your main program. On the other hand, if I'm defining A within an inner block within the same method, then it'll give me an error. These are the kind of the picky things you see that they put on an exam if you want to get certified. It's not something you really worry about overly in programming. I always tell people when they're programming, put all of your variable declarations at the top. Don't have it mixed in here. It makes it so hard. If you're trying to see what something's declared as, it should be at the top of the method, the very beginning. You can have it spread throughout, but then it causes issues like this. Like here, we got B declared. B is equal to 7. I can use B here. That's just fine. But at, okay, let me think about this. This appeared to be it's on the same level as that. That's where those declarants, I can use it there, but I cannot use it on the outer here. So, what's the benefit of just declaring it within that one little piece? Is after it gets done running that block, it releases that memory. So there are reasons why you'd want to do that. Let's see, what's this one do? Eat more, two variables coming in. Room and belly equals 5. If hungry, that's fine. Boolean, we're declaring this within that if block. While amount of food is coming up here at this level, so it should be available throughout the entire method. It's greater than 0. Amount eaten. The amount eaten is declared within a while. Wish I could put 2 pages on 1 page here. Actually, I don't think they indicated it was an error. Just wants to know when it's goes in and out of scope. Um, the These two, hungry, amount of food is available throughout the entire method. Room and belly is available throughout the entire method. Time to eat only exists in this if part. Amount eaten only exists if you're in the if statement and you're in the midst of the while loop. Now I'm lying about that. Not in the while loop. Amount of food is equal to amount of food minus amount eaten. When do you think amount eaten exists? It only exists for each run within the while loop. If that while loop is called 100 times, it declares and assigns a value in memory for each run through that while loop. And after that while loop is done, then it gives that memory back. So if you were worst case calling this 10,000 times, you'd be allocating memory 10,000 times and assigning it and so forth in memory. This is why putting an int at the wrong place can create a lot of overhead. Okay, they talk about all that. What should we have handled? Going to figure out the type of the 4 variables when they go in and out of max length by doing a static makes it available across the board, not just within this class, but within any class. So I can access max length from outside of this class. Length is only valid while I'm running this particular, while I'm inside this class. This is not a method. Inches here only is in scope while I'm inside this public void grow, this method.
This new size is only within scope. I can only use it when it's in that method grow, and it's in that if statement. So when length is less than max length. Okay, so that was sum it up. Local variables in scope from declaration to end of block. Instance variables in scope from declaration till object garbage collected. And the class variable in scope from declaration until the program ends. Kyle, in game development, although you see me be sloppy about it, where I like to put things as static so I can access them directly from other classes from anywhere in your game, it isn't necessarily the best way because it keeps everything in memory throughout the entire game. So it makes programming easy, but if you got a huge amount of items that you're storing off and it's keeping it all available um, in your RAM and so forth, then that's not good. Um, this talks about ordering elements in a class. I guess the only thing I really tell you is the order doesn't matter on these. Um, or I mean it being required doesn't matter, except for the first one, which has to be public class. Where does it go? You're declaring a package, it has to be the first line. If you have an import, immediately after the package. You can't mess this up. If I come down here, it's going to give me an error. So you can't put it down there. Then the class declaration comes after the import. Your field declaration, like int, you can put that anywhere, which we've seen. The method declaration, anywhere inside a class. When I created this public void test here, at first I was drawing a blank because I was trying to think, where does this go? And then I remembered that it can be anywhere inside the class. In C programming, if you program in the C language, your has to go down here. And then you put a function prototype up here at the top. So you can't just put it anywhere. Different programming languages handle it differently. Some will say it has to be before it's. You have to declare it. You have to design it, have all your code and everything before it's used. Otherwise, it gets an error. C has a look ahead. That's what the function prototype says. It says, "Hey, I'm going to have this," and then the actual definition of it is down here. Other programming languages do a pass through. So when it does the compile, it goes through and does a pass through and sees all the different methods available. And then it comes up to your main one, and it doesn't matter the order, which is probably what this does. Because if I take this, and paste it down here, I don't think I have any more errors. I get some more errors. Get rid of that. I'm calling test, but it has never seen test before. So when you compile this, it does a pass through. It does a first pass where it goes. Well, I don't know what pass it is, but it does a pass through where it goes and gets all the method names and how they're defined. And then it comes up here and says, "Okay, test. I've seen that. That's down there at the bottom." So this is just telling you it's okay to put it anywhere. I can go over those.
destroying objects. Okay, so got that. As on line 3, we write 1 and 2. Just words. Oh, let's talk about the. This talks about how you can, if you're working with objects, this finalize. Java allows objects to implement a method called finalize that might get called. This method gets called if your garbage collector tries to collect the object. If the garbage collector doesn't run, the method doesn't get called. If the garbage collector fails to collect the object and tries to run it again later, the method doesn't get called a second time. This practice means you're highly unlikely to use it for real projects. Luckily, there isn't much to remember about finalize for the exam. Just keep in mind it might not get called. And it definitely won't be called twice. Java tries to clean up the memory as it goes along. Some program languages don't do a very good job of that, and that was one of the things I liked about Java. Here are some key benefits. It's object oriented. We talked about. Encapsulation. Java supports access modifiers, protect data from unintended access and modification. And we've seen that, where you can make things private, and so you can't access, you can't modify it. You have to do gets and sets. Platform independent, we talked about that. Creates bytecode, you can run anything. It's robust. One of the major advantages of Java over C++ is that it prevents memory leaks. Java manages memory on its own, does garbage collection automatically. So you do not have to program it. It goes through and does it. And that's what that finalize talked about, is that you can control saying, hey, no, don't mess with this. Bad memory management in C++ is a big source of errors in programs. Garbage collection, one major area of it is how do you reallocate memory? So you can use it again in the program, or you can give it back to the operating system. Program that's written in C++, if it's not doing the garbage collection correctly, can keep using memory over and over, and then all of a sudden your operating system won't work. That's what Excel did way back when, and it still has memory issues from what I've read. It doesn't do that garbage collection correctly. So when it quits using like an object or even maybe a worst case a primitive type, then in theory you'd like that to go back to the program and maybe even the operating system when the program quits running. But again, it doesn't handle that. This is not easy. I don't think I could do it successfully in C++. I can, fumble around through it in a programming book, but to do it in real life, if the Microsoft programmers can't do it in Excel, well, that tells you it's not a simple thing. And for Java to handle that was a major issue. Java is simpler than C++. Gets rid of pointers. Pointers are a pain if you ever taken C. Java code runs inside the JVM. Okay, that's the end of that chapter. Talks about exam essentials down here. And looks like I'm out of time. But yeah, so that works out well. I would recommend you go through here and read this. Some of it's very fine particulars that you necessarily wouldn't need for your average Java programmer, but it's actually kind of interesting information, I think, from a programming standpoint. But we won't have any programming project out of this since I am out of time. So we'll call it quits there, and we'll go in chapter 2 next time.